Hello everyone. Thank you for joining us today. I am G. Kaushik. I have worked on an IoT based home automation system during my internship at emertxe, and I am here presenting my PowerPoint presentation today. My goal is to explore the fascinating world of the Internet of Things and apply it to create a smart home solutions that make everyday living easier and more efficient. During this internship, I learned about the embedded systems, sensor integrations, and cloud based control platforms. I am excited to share how I designed and implemented this project step by step, combining technology and creativity to build a connected home environment. Internship overview. Now, let me explain what I have learned in this internship. This internship primarily aims to build understanding of Internet of Things and embedded systems, learn the relevance and the role of IoT in everyday applications, evaluate participants through weekly assessments, reinforce learning using stimulation-based projects, offer mentorship to beginners entering the IoT domain. Next, I am going to explain the concepts covered in this internship. C programming. C programming. Topics include keywords, data types, operations, loops, arrays, functions, pointers, and memory uses. C++ programming. Focused on object orientation programming concepts. We learned about IoT, definitions, architectures, and practical uses, and embedded system. In embedded system, we learned key peripherals such as Arduino, Uno, LEDs, CLCD, sensors, and PWM concepts. The next slide is about C programming. C is widely respected general-purpose programming language designed in early 1970s by Dennis Ritchie at Bell Laboratories. Known for its portability, C is both powerful and efficient, forming the backbone of operating system, application software, and embedded systems. Its syntax encourages structured programming, enabling developers to organize code into well-defined functions, manage memory directly, and implement complex logics using variables, constants, and a variety of data types such as integers, floating points, numbers, arrays, pointers, and user-defined structures. C supports procedural programming, recursion, and static type checking, which helps the programmer write clearly maintainable programs while maintaining high performance. This language, concise and readable syntax make it accessible to learners. Yet it flexible encourages for experienced developer to create efficient software for diverse platforms. About C++. It is an object-oriented language. Support key concepts like classes, objects, encapsulation, inheritance, polymorphism, and abstraction. C++ allows both high-level and low-level programming, make it suitable for software development and large-scale application projects. The language is statical typed, meaning variable types are set at compile time for better performance and error detection. C++ programming are mission independent and portable code can run on any platforms with the appropriate compiler. It is compiled and provide fast execution, make it preferable for performance at critical applications. C++ supports features of both procedural and generic programming in addition to its object-oriented paradigm. Introduction. The key concepts include smart lights, thermostats, locks, cameras, applicants, motion sensors, actuators for controlling physical like binds or values. Automation enables scheduled routines or trigger-based actions. Example, lights turning on when motion is detected or temperature adjusting based on presence and action time of day. Security is enhanced with smart lock alarms, door sensors, surveillance cameras, and instant notification of unusual activity. Voice assistants such as Amazon Alexa, Google Assistant can be integrated for hand-free operations of devices or custom automation. Smart home systems save energy, increase convenience, enhance comfort, and improve the safety of the home environment. Moving forward, I am now going to explain about Internet of Things. Internet of Things is a network of physical objects such as devices, applicants, or sensors that are embedded with the technologies allowing them to connect and exchange data over the internet. IoT system consists of three core elements: smart devices, connectivity infrastructure, and data processing mechanism. Smart devices gather environment data and send it through gateway or network protocol like Wi-Fi, Bluetooth, Zigbee or cellular data, enabling interaction and remote management. The data collected in it is then analyzed, often with AI or machine learning algorithms, to create actionable insights, trigger automation or alert users about the significant events. User interaction with the monitor IoT devices primarily through graphical user interfaces like mobile apps, dashboards, or web portals. Next, this slide shows the architecture overview of Internet of Things, supporting my explanation of previous slide. Now I am going to talk about challenges faced in IoT. Security. IoT devices are frequently targeted for cyber attacks due to their network connectivity and often weak security features, making robust protection a top priority. Privacy. Massive data collected by IoT systems create serious concerns around user privacy and unauthorized data access. Interoperability. Devices from different manufacturers must communicate seamlessly, but lack of standardization can cause compatibility issues and fragmentation. Scalability. Managing, updating, and tracking the rapidly growing number of devices in a large scale IoT deployment is increasingly complex. Connectivity. Reliable and unambiguous network access is critical for IoT, but often difficult to guarantee in remote or infrastructure limited areas. Cost. The expenses involved in designing the deployment and maintaining IoT networks can be higher, especially for smaller organizations. Now let us discuss the solutions related to faced in IoT. Implement robust security protocols such as encryption and strong authentication mechanisms to safeguard devices' data and prevent unauthorized access. Update softwares and firmware regularly to fix vulnerabilities and ensure devices to protect against evolving threats. Using zero trust segmentation and network policies to limit access between devices, contact threats, and minimum attack surfaces. Deploy advanced threat detection technologies include AI and machine learning system to monitor networks for suspicious behavior and automate response. Standardized device interoperability through accepted communication protocols and well-defined APIs addressing compatibility issues between devices. Assign unique cryptographically based identities to devices to track and authenticate each unit throughout its life cycle. Next is embedded system. My project is built on embedded system concept. An embedded system is a specialized computing system designed to perform dedicated tasks of controlling specific functions with a large devices or applications. It is typically consists of microcontrollers or microprocessors, memory components, RAM, ROM or flash, and inputs-outputs interfaces for interfacing with sensors, actuators or user controllers. Embedded system may include supporting software such as real-time operating systems (RTOS) and application programmers, enabling them to execute instructions and react to environmental changes. These systems are optimized for efficiency, reliability, and minimize size, and for widely used in products like smartphones, household applications, medical devices, industrial machines, vehicles, and automation systems. Unlike general purpose computers, embedded systems focus on performing specific operations, often with real-time constraints, low power consumption, and cost efficiency hardware tailored for target tasks. Now let us see the project requirements that are needed in my project. Microcontroller. Arduino Uno is used as our core microcontroller. Second, the modules implemented in my project: garden light control and temperature regulation and cereal tank management. Displays and shields that are used in my project are CLCDs and Ethernet shields, and simulation tools that are used to develop and test each prototype before physical execution. The following are simulation tools that are used for project implementation: Arduino IDE, platform for writing code and complexing into HEX files for deployment. PixSimLab, virtual environment for simulation hardware and executing the compile files. Null Emulator, Blink IoT app helping control systems like temperature and tank management remotely. In the following way, I implemented my project. A folder is created in the name of the project, includes file name like home automation, blink control, like this, and created. After coding in these files in Arduino IDE, export compiled binary file of the INO file. In PixSimLab arrangement, parts like LED, LDR, LCD, temperature systems, Ethernet. Load hex files for Arduino Uno board in PixSimLab to view output. Use Blink app in mobile to visualize and control the system. This is the detailed explanation of Arduino Uno that is used in my project. About Arduino IDE software. Arduino IDE is a software platform used to write, compile and upload code to Arduino boards. It provides a simple interface for coding in a language similar to C and C++ designed for Arduino hardware interaction. Features include cross-platform supports, built-in code editor with syntax highlighting and automation formatting. Include a compiler that converts code into machine-readable instructions for Arduino microcontrollers. Support one-click upload of code to Arduino boards via USB. Library managers facilitates adding custom libraries easily. Serial monitoring is available to debug and view data sent from Arduino board. The interface has components like code editor, toolbars to verify upload, new open save files and serial monitors, message areas and board port selectors. About PixSimLab. PixSim stands for Programmable IC Simulator Laboratory. Is a real-time emulator for development boards that supports microcontrollers from various simulators like PixSim, SimAVR, USim and GPSim. It integrates with development tools such as AmpLabX, Arduino IDE and VS Code with platform I/O for programming, debugging and uploading code, but it does not provide its own source code editor. Next, we will talk about our Blink app. The Blink app is a part of cohesive low-code IoT platform trusted by over 1 million developers worldwide. It enables users to build and customize feature-rich IoT mobile apps without writing code. Blink simplifies the entire IoT process, includes device activation, Wi-Fi provisioning, remote control, sensor data visualization, OTA firmware updates, and secure cloud connectivity. It supports over 400 hardware boards and various connection methods include Wi-Fi, Ethernet, cellular, LoRaWAN, HTTPS and MQTT. Now we will discuss about the temperature control module we use in our project. It consists of heat resistor, LM35 temperature sensor and cooler resembling a home temperature control system. Read temperature and display it on CLCD. Control heat and cooler on off through Blink IoT mobile app. Next, we will understand about garden light controlling system that we use it in our project. LDR sensor is used light dependency resistor. Resistance changes with intensity of light. Sensor detects change in resistance to control garden lighting. The third module that I have used in my project is water tank controlling system. Reads volume of water in a tank through serial communication and displays in CLCD. Control water volume by controlling inlet and outlet valves via serial commands. Notifications and volume display on Blink mobile app. So as you have already seen the presentation part from my, and now we are here to implement this project in real life application. We have used some kind of technologies like Bing Cloud and some Arduino, about board up. So this is the main file, automation, blink control and more, and I have integrated all different files into one file. As you can see, the LDR1, the serial tank and the temperature control system, and the main file where I have initialized, or I can say where I have set the pin port as I show here. So now let me move to one file, the main file. Here the very first part of the code is authentication part, where I am configuring my authentication of Blink application through my credentials or configuration files. So now moving forward, here I have included some header files such as SPI, Blink system and so on. Going through further, the code is already explained through the presentation time. You know already see the videos. I don't think I should explain here again. So the code explanation portion is done here. So now let us quickly move to the simulation part, and I will show how the exactly things are working. Let me just open the Pixim lab quickly, and the Pixim lab, and I am using both, and I have loaded my X files. I have did the previously, so I just reload the last X files to show as a part. So just start the simulation. So first look at our garden lights, green light system, which we have used some components like LDR and LED. Like you guys see, if you control through LDR side, the light sensitivity of LED or brightness changes according through the resistance, which we have learned through our internship training period. So this is how the light system works. And moving to our second objective, so here we have, like you can see, Bing applications which I am using in my smartphone. I had a couple of buttons and a couple of pages on my home automation tab. So if I click on the color, you can see the color turns and the temperature decreases, and if I click on the heater, the temperature increases as we turn on the heater. I have given some conditions for the temperature to, like, in this notification we can see the temperature about 35 degrees centigrades. Turn off the heater. So the turn off the heater, the temperature automatically downs, so we can use the cooler. Temperature widget, you can see the temperature quickly reduces to 27.34 degrees. So this is my serial remote time. So I have made a separate tab for two, and I have included two values, that in inlet, so outlet value. So if I turn on the inlet value, the water level fills up, and see it filled up to 3000 capacity. So now you can see the LCD also cooler, and the volume V avails up to 3000 and inlet off. Coming to, you can see the notification of the tank is full and the inlet is automatically turning off. When I turn on the outlet valve, the water reduces and flow out until get the some conditions in the code. So let's see if it is successfully executes or not. As you can see, the water is below 2000 or equal to 2000, the inlet valves automatically turn on and the outlet valve stops if the turn off and shows the notification too. This is how the serial tanks works. So now conclusion. Using Blink IoT application and Pixim Lab simulation home automation, where LED temperature system serial tanks resemble light heater, cooler and water tanker in real time. CLCD act as dashboards. Blink app widget controller heater, cooler, inlet and outlet valves. IoT involves increasing number of smart interconnected devices and center used in home automation. IoT bring technological changes, make life simpler and more comfortable. So before we conclude, I would like to sincerely thank LMS and our mentors for providing this wonderful internship opportunity. This experience was invaluable for building our skills and deepening our understanding of IoT and embedded systems. So we are truly grateful for the guidance, support and resources that made this project. Thank you.